My name is Shadir Sajjad. I am from chemistry department and in this video I will discuss about testing methods of hair colors. First I will discuss about chemistry and theory. The chemistry of testing methods of hair colors involve applying chemical principles and analytical techniques to assess the efficacy, stability, safety and interactions of hair dye formulations with hair fibers and other materials. The theory behind testing methods of hair color lies in evaluating performance, safety, stability and aesthetic results of hair dye products using scientific and standardized procedures. These tests ensure that hair colors are effective, safe for consumer use, and retain their quality over time. Now I will discuss about procedure and scientific logic. First is color measurement procedure. Dry hair traces or synthetic fibers using the test formulation. Rinse, dry, and comb the hair uniformly. Place the sample under a colorimeter or spectrophotometer. Record light, red, green, yellow, blue values. Compare with the standard or untreated control. Purpose to determine how closely the dyed color matches the intended shade and how vivid or dark it is. Scientific logic. Color is the result of selective absorption and reflection of light by dye molecules. Using lab values, we quantify shade, lightness, and color accuracy. Next is light fastness test procedure. Dye several hair traces with test product, expose them to UV light for a fixed time, keep a set of identical traces in the dark, measure color before after exposure using a spectrophotometer, calculate total color difference. Purpose to assess the photo stability of dye and its resistance to fading under sunlight. Scientific logic. Photodegradation occurs when UV light breaks the chromophores into dye molecules. This test stimulates sunlight to evaluate how well color resists fading. Next is wash fastness test procedure. Dye hair traces and allow them to dry completely. Simulate washing. Warm water. Standard shampoo solution. 10-minute agitation. Collect the wash solution. Measure the amount of dye in the solution using UV visible spectrophotometry. Alternatively, assess color changes on the trace via colorimetry. Purpose to determine how long the hair color lasts with repeated washing. Scientific logic. Dye molecules that are loosely bound to hair or not oxidatively fixed with leach out during washing. This measures dry affinity and water resistance. Oxidative stability test procedure. Store dye formulations at various temperatures for 1 to 3 months. At certain intervals mixed with peroxide and allow color to develop on paper on hair. Measure the intensity of the developed color using spectrophotometry. Compare with freshly prepared product. Purpose to test the product's chemical shelf life and its reliability under different storage conditions. Scientific logic. Oxidative dyes rely on reactions between primary intermediates and couplers in presence of hydrogen peroxide. Over time or improper storage, these can oxidize prematurely. Tensile test, strength test procedure. Cut uniformly hair samples, dye them with product and rinse. Mount each hair fiber onto a tensile testing machine. Pull the fiber at constant rate until it breaks. Record breaking force and elongation. Purpose to assess structural damage caused by the dry formulation. Scientific logic. Dye chemicals can damage keratin by breaking disulfide bonds and degrading proteins, weakening hair. This test evaluates the mechanical integrity of treated hair. pH testing procedure. Calibrate a digital pH meter using standard buffer solutions. Dip the electrode into dye cream or solution. Record the pH reading. Purpose ensures the formulation is within safe and effective pH range. Scientific logic. The dye's performance, stability, and scalp compatibility are pH dependent. Permanent hair colors typically work at alkaline pH, which is about 9 to 11. Fast test procedure. Apply a small amount of dye behind the ear or on the inner elbow. Leave undisturbed for 48 hours. Monitor for signs of redness, swelling, itching, or rash. Purpose to check for individual allergic reactions before full use. Scientific logic. Common dye ingredients can act as contact allergens, triggering immune responses in sensitive individuals. Microscopy. This is another step. Procedure. Dye and rinse hair standards. Prepare samples for observations. Examine using light microscope or scanning electron microscope. Look for signs of cuticle lifting, erosion, cracks, or splits. Purpose. Visual assessment of physical damage caused by dyeing. Scientific logic. The hair cuticle protects the cortex. Damage from dyes can lift or strip these layers. Now I will discuss about applications. First is patch testing. This is an important test for hair colors. This helps prevent serious skin irritation or even more severe allergic responses across your entire scalp and face when you color your whole head. It is crucial for consumer safety. Next is color prediction. This helps you avoid unwanted surprises like the color turning out too dark, too light, or having an unexpected tone. It ensures you get the color you are hoping for. Quality control. This is vital for manufacturers to ensure their products are consistently safe, effective, and meet quality standards before they reach store shelves. It also helps them troubleshoot any issues with color fading or unexpected results. Hair health assessment. This helps hairdressers choose the right type of dye and application method to achieve the desired color without damaging your hair. Future recommendation. The world of hair coloring is always evolving, and future testing methods will focus making the process even safer, more personalized, and environmental friendly. Here are some simple future recommendations. First one is advanced virtual try on. What it is? We have apps and websites where you can try on different hair colors using your phone's camera. What it will be? This will become incredibly realistic. Imagine trying on a color and seeing exactly how it looks in different lighting conditions, how it reacts with your skin tone, and even how it might fade over time before you apply it. It could even consider your hair's unique texture and color condition. Why it is useful. Less guesswork, fewer bad hair dye experiences, and more confidence in your color choice. The next was in micro testing, which is also called personalized allergy and sensitivity testing. What it is? The patch test is where you apply a teeny bit of hair of dye to your skin. What it is? Instead of just a simple patch test, imagine a small smart device that you wear on your skin. The device could test for reactions to specific ingredients in the hair dye at microscopic level, giving you much more detailed and accurate safety assessments. It might even be able to analyze your skin's unique chemistry to predict reactions. Why it is useful? Significantly reduces the risk of allergic reactions by providing more precise and earlier warnings, especially for people with sensitive skin or non-allergics. Hair health scans before coloring. What it is no. Hairdressers often visually check your hair's condition. What it will be. Imagine a quick scan of your hair using a special device. This scan could tell you exactly how porous your hair is, its current damage level, and even predict how a specific dye formula will interact with your hair's unique structure. Why it is useful? It helps prevent damage, ensures even colored application, and allows for personalized dye formulas that protect and nourish your hair. Next is fade predictors and color longevity test. What it is? You hope your hair color lasts. What it will be? Advanced lab test and possibly even at home tools that can accurately predict how long a specific hair color will last on your hair type before it starts to fade. This could involve simulating washing, sun exposure, and heat styling. Why it is useful? It helps consumers choose long-lasting colors and manage their expectations, reducing frustration with premature fading.